Hey everyone, CyberCDH here. Today we're going to take a look at a malicious sample called LOLSnif. It's quite an interesting sample this because there's tons of anti-analysis tricks built in. The first being that the malware is super obfuscated. I'm going to show you the tools, the tactics and the techniques that I use to super quickly turn malware which looks like this, which is full of arrays with integers, loads of constants, loads of weird comments and code all over the show, into something that looks like this, that's super readable. We have registry keys, we have file locations, we have file names, we have IOCs that we can use to then go and protect our environment from this malware. How do you get from this to this? I'm going to show you, so stay tuned. Okay, so what we're going to do first is just quickly eyeball the code, and we can just have a look and feel for any bits that we want to get rid of. So straight away I can see comments in this code which are worthless, just thrown in for noise. So anything that starts with the string rem for remarks, or an apostrophe and a space here in VBScript will be a comment. We can get rid of those, and we can see we've got a number of arrays here. We've got loads of arrays which contain loads of integers and also variables, and also there's some arrays here which also contain just what look to be random strings of text. We can also see there's some calls to execute global, and that's just the parser there is going to execute whatever you feed it as a parameter, and in this case it is the product of this user-defined function HIYCK, and that takes one argument which looks to be an array of integers. So each time it's being passed a different array of integers, and so we want to know what that function does as well. First thing to do though, let's tidy the code up just a little bit. So what we can do, let me actually start by making a copy of this code. We'll call it copy.vbs, and then we'll cat copy out, and then we will use, no we won't use all, we'll use sed, and in this particular case what we'll do is we'll delete, we use the /d kind of parameter from sed, anything which any line which contains an apostrophe and a space. So that worked, and then also what we'll do is we'll pipe that to sed again, and anything which starts with rem space, we'll also delete that as well, which is good. And what we'll do is we'll just pipe the output to stage2.vbs. Go back to Sublime here, let's open stage 2, and now we've got the code just without those comments, which might make it a little bit more readable. In this case, not too much show, but at least we've cleaned up a little bit of noise. Now what I want to do is I want to strip out the stuff that's interesting. So we've got this user-defined function that's here, and so we'll take a look at that in just a second. But before we do, I want to strip out all of the arrays that contain integers, because they seem to be the ones that are being passed through to that, this function, this user-defined function. And I also want to strip out all of the constants as well. So again, we'll use some commands here in our terminal window. Let's cat out copy, and then what we'll do is if we grep out everything that contains the word array, we're going to get all of this, the noisy stuff, i.e. the random strings. But we'll start with that, and what we'll do is we'll pipe it to grep again, and grep -v array, and we'll escape open quote, open bracket and an open quote, and it'll just give us all of the arrays which have got the integers in there. So we'll t-a that to out.vbs, and we'll start building up our code. So let's come back into Sublime, open out, and we can see we've just got a list now of all of those arrays, and they're the ones that we're interested in. Let's come back here, let's cat copy again, and we'll grep anything which starts with the string const, and you can see here, so all the constants which again associate with more integer values. So we'll just t-a that to out.vbs as well. Come back into out, it'll refresh here. So we've got all of the arrays and now all of the constants. Come back into copy. We saw before, where was I? Stage 2. We've got this user-defined function. That's what we're interested in as well. Let's copy that out and let's paste that in down here. And so let's just take a quick look at what that function actually does. It takes a parameter, and we know those parameters are the arrays of integers. It loops over each element in the array from 0, the lower bound of the array, to the upper bound, so to the length of the array. And then it builds a string here called lx54, and it does a character conversion here. It takes whatever value we're looking at in the array and does minus whatever this equates to. And I don't know what this equates to off the top of my head, so we'll use Google, and we can see that equates to 76. So it's going to take whatever value in these arrays. So pick one at random, I guess. So it's going to take, like, the first one would be 300 here, and it's going to minus 76 from 300 here, 147, 95, etc. And then it's going to convert the integer into a character. So it's, you know, if you imagine it on the ASCII table, you know, you can represent a character either by a decimal, hexadecimal, octal, etc., or obviously in its letter alphabetical format. So we're going to build up a string here. So super simple character decoding routine here. This array just thrown in for noise, so we can get rid of this line completely, and then the return value is going to be that string. So next, what we want to do is we want to get everything that's all the lines that are being called to execute global. So let's cat our copy out again, and we'll grep everything that contains execute global. Well, you can see here there's a couple of problems. So first off, we've got like lines here which have got multiple things on the end of them. And so we want to get rid of these. So you can see that they're concatenated by these colons. So let's go back into copy. We'll do find a colon in the open file, and we'll replace it with a colon and a new line. We'll see if this works. 29, yeah, let's replace them. Save it. Just to break up that concatenation. There we go. So we just get these stuff for execute global, and we get just the calls here that we're interested in. But what I want is just these bits in the middle, or at the end rather, which are the variable names, which are the arrays that get passed into that user-defined function. So what we can do is we can use awk and a field separator of an open bracket, and then what we want to do is print. No, I don't want one of these. Print the 1, 2, 3rd column in the output, which is going to be that. So not too clear because we've got the stuff on the end. So on the end, we can use, we can change the close brackets using translate. So let's do, what do we need to do? Escape it. And we'll translate that into a space, and we can do the same again. So we'll pass through to translate again, and we'll translate a colon into a space as well. And that just gives us, let me clear this up, that just gives us a nice list here of the array, the variable names which contain the integer arrays, which are all passed to execute global. But rather than have it just all in one line here, what I want to do is actually have a comma separated list of these, because what I want to do is actually loop over them myself, and I can't be bothered copying and pasting these, so I'll get awk to do the work. So what we're going to do is we're going to do awk, but we want to use printf here. And so printf allows us to use like format strings. So what we can do is say we can paste in like a %s, which will be the string, i.e. the string in this list here, and we can also add a comma to it as well. So let's why don't we do that? Let's paste that in here. We want %s with a comma after it. We want the first entry in the list because there's only one of the columns. We'll close that out and print it. And there we go, ignore the thing on the end, but we've now transposed that list of new lines into something which is separated by commas. Let's come into out.vbs, our code down here. And what we've got here, we've got like arrays. So we'll declare this ourselves. So we have like an array of all of the variable names, all of the array variable names that get passed using execute global. Now what we want to do is pass them into this function ourselves, so we can use the same kind of logic. So we can say for I equals L bound of arrays, spelled it wrong, to U bound arrays, and what we want to say is we'll just say X equals and then the call to this function, and we'll pass in arrays I, the ith value, and then we can VBScript.echo whatever's in X, and we'll say next. Right, hopefully I've not made any mistakes there. Let's go to a virtual machine. Let's plug this into a blank VBScript file. We'll pass it to C script. What do I call it? YOLO. There we go. Right, so it's nicely output for us. So we'll output that to decoded.vbs. We'll edit that, copy and paste it, come back into Sublime because it's easier to read. We'll save it as decoded.vbs. Get rid of these first two lines here at the top, and now we've got something which is a lot more readable. We've still got some comments here, so we need to do the same thing actually. So let's do cat decoded, and we'll do sed again, and get rid of anything which starts with the apostrophe, and so we'll delete that, or anything which contains apostrophe, which will be a comment line. So hopefully that's going to work. Yes, and also we can sed as well using the same format. Anything which has rem. Let me just do that, don't I? With sed. Yes. Okay. So, and then we'll do decoded to. Oh shit. Let me go back. -d, that one, right? And then we'll t-out that to decoded to.vbs. There we go. So it should be a little bit cleaner. Decoded to. Here we go. Right. We've also got these arrays. Ah, gosh. Right. Tell you what we do is grep -v. Anything which contains the array thing again. So that and the quote, and then pipe that to decoded3.vbs. Boom. So hopefully we'll have some results here. Right, there we go, nice and clean. So we've got functions here without the noise. A little bit of stuff we'd have to calculate and work through. We can see he selected this function is looking at the logical disks, and it's doing some comparison to the size. We can see here this looks like a function which hits a C2, so you pass it a parameter which is the URL. It will do a GET request and give it a specific user agent. There's a check here for the GeoNation identifier within the registry. There's also a check for the file system name, or rather that reads the file, this particular file name. And we can see here there's a zip file which looks like it's created. We can see there's a text file, looks like it's created. There's also, it looks like there's doing some comparison here for the last boot up time. We've got some other indicators of compromise as well. We've got the, it looks like to be C2 here. We've also got a process name, etc., etc. And if we scroll down a little bit, we can see actually there's another function, this spacesuit function here towards the end. It looks like it creates a stream here to write something to file. We can see there's a for loop, which is looping over a bunch of other arrays. So these are variable names that it's looping over, but these are other arrays within that massive list, within this list here. And it's looping over them and decoded them and then writing them to a file. So we can replicate this as well in our code. Let's go to out.vbs. Let's get rid of this lot. There we go. And then what we don't want to save it to stylish plus Dean. We'll just save it to dean.zip because I don't know what stylish equated to. It's probably somewhere in the temp folder or what have you. So let's see whether this works. Let's go back into our VBS here. Let's close this. Edit this one. Delete that. Paste it. Save it. Done. Right. C script YOLO.vbs. We can see here it's dropped the dean.zip. We can extract it, we can open it, and there's the executable that's buried in it. So this VBScript is going to drop an executable. Looks like it's got some other files along with it, which no doubt are like encrypted configs or what have you. And the first thing I would do is stick that exe in PE Studio, which is an awesome tool for malware initial assessment. Straight away you can see the results from VirusTotal. Looks like URSNIF or GOSI, whatever you want to call it. You can see the file headers, you can see the imports, the strings, the debug path, the version, whatever. An amazing tool so you can quickly kind of get to grips with what this malware might be, and you can further reverse engineer it. So that is how you go from code that looks like this to code that looks like this in just a few minutes with just a few kind of shell Linux commands. Hope that was useful. Certainly had fun making this video, and I welcome your questions and comments. Thanks everyone. Bye.